Right, good afternoon. Today we're going to be revising mathematics grade 12, preparing for paper 1. As we've discussed, we studied quadratics today. So there's a series of questions that we're going to do today. So please have your calculators handy. And then after this session, we'll do finance, because we cannot get an extra class, so we'll be able to use the online videos. And for those who are not here, you can watch the video at the later stage. And then we start with your question 1 that we're gonna get in paper 1 grade 12 papers. So I've combined a series of grade 11 and grade 12 questions, so I can be able to be ready for the examination come Friday. And all the best. And this is what we're going to do. I hope the whole screen is visible. We'll be dealing with such problems in question 1. We call them quadratics. So there's different types of them and different methods of how to solve all of them. Let's start with the first one. These are the basic solving for x, where you have to find the factors. The examiner might also give you the factors. For example, this one will elaborate more about it. You see that it's already been factorized. Some of them will not be factorized. We'll do more examples of those. And then we have your quadratic formulas, where you're supposed to use your quadratic formula. You see with the keywords, when they say correct it to decimal places, that you need to use a calculator for that. So we'll also have a few examples of those. Then the inequalities, where we have seen that most of the learners, the previous learners, has actually lost marks in inequalities because on how they are solving it. Taking this inequality as an equal sign is one of the misconceptions that learners are actually doing. So we hope that you're going to avoid that. We also have inequalities. And then I've also placed problems that need us to use the K method. We will also have few examples of such problems where you need to bring in your own variable to make sure that you are able to solve the equation with ease. Now let's jump right into it. Let's start with the first one that we've seen. I've also shared the series of those question papers with you guys, and we also like to acknowledge the Department of Education for providing us with this material, and then the APOC Science School for making it possible for us to record this video in their premises for the Apex grade 12 learners and anybody who would like to benefit from it. So let's start with the first one. Hope red will be more visible than the rest. So you see that you have x open bracket, then we have 2x plus 1. So we're going to use the concept that says when you have a, when you multiply by b, will give you 0. Remember we were taught in grade 9 to say any number you multiply by 0 will give you 0. So we're using this concept to say if we make a equals to 0 or b equals to 0, the whole thing will be 0. So it's either a is 0 or b is equals to 0. Either way, we will get our right hand side being equals to 0. So another misconception that you need to avoid is that you cannot say a multiplied by b equals to 2 and then you say a equals to 2 or b equals to 2, because the concept is not the same as this concept. So this concept only states because we know anything multiplied by 0 will be 0. So we cannot use this concept for any variable. So you need to transpose this to the other side. So we're always looking for 0 on the right hand side. So we have a 0, we have achieved that, and then we have two terms that are multiplying each other. We have a binomial this side and we have a monomial this side, so we'll say x equals to 0 or 2x plus 1 being equals to 0, and our x is 0, and on the other side we'll have our 2x being equals to negative 1. Transposing this to the right hand side, we'll change the sign, and then we'll have x being equals to negative 1 over 2. In most instances it's just 2 marks, because the skill they are expected to know it from the previous grade. US grade 12 will just be given 2 marks. I think even the grade 11s will just be given 2 marks. So what I wanted you guys to guard against is to say, if it's already factorized, there's no need for you to expand, especially if you are solving. Remember, when you are solving, you're gonna have to factorize, and then if you are simplifying, you can just expand, but you are actually solving here, so you need to get the value of x. So with this problem, it's very simple because they've already have factorized for us. And then let's move on to another example. If we move on to another example, let's close this one, save this for later. I'll try to also increase my handwriting. Now let's look at this one. This one is not factorized. We're still solving for x for this one, so it means that we have to factorize for ourselves. And remember, you need to know how to factorize in grade 12. So let's look at the factors of. Let's look at our factors of 30. So the factors of 30 is 30. We also have 5 times 6. We have 3 times 10. These are the factors that we know. So I'm going to pick the ones that are very close to each other because I see that I need to get 1. But by now you have that space at grade 12. So I'm going to open the bracket, and then this must be equal to 0. Good that we have 0 this side. So we have x multiplied by x will give us that x squared. And then we see that the constant has a negative sign. So we're expecting the two brackets to have different signs. And then if the middle term is positive, it means the bigger term or the bigger factor must be positive. So I'm going to take 6 and then put 5 this side. And then we're going to have x plus 6 equals to 0. Or we're going to have x minus 5 being equals to 0. and then we transpose this to the other side, our x will be equals to -6, or x will be equals to a +5. Because when you transpose to the other side, we change the sign. And let's say for example, you had a problem like this one, but you had x squared, maybe plus x, then minus 30 equals to, let me say for example, is equals to 8. You cannot factorize this side. Let's say x plus 6, x minus 5 equals to 8, and then you say x plus 6 equals to 8, or x minus 5 equals to 8. This is incorrect. That's a misconception. You cannot do this. So you need to first transpose this to the other side and then factorize afterwards. And then you can only equate, because we're using the concept of a multiplied by b being equals to 0. If you have any other number except 0 this side, you cannot use it to solve for the value of x. You just be making assumptions which are actually a misconception. So please check that one out. This is the total no. You shouldn't do that. You always have to make sure that your right hand side has a 0. So if you need to do more of these examples, look at the previous question papers, pick any of them at random. You can pick the grade 11 ones. You can also pick the grade 12 ones. Because remember, algebra is not done in grade 12. It was done in the previous grade from grade 9. Actually, from grade 1, you've been doing algebra until you got to grade 11. So we are testing everything that you've learned in the past 11 years. So in grade 12, we're not doing it. There's no any other new concept that we are putting in grade 12. We're just testing it. So this is just a revision, because it will also be included in each and every paper from now on. Grade 12 paper. So let's move now to the next question. If you have any questions, please, you can timestamp on the comments, and then I will be able to answer them at a later stage, or you can send them via the group. Then when we are done with this session, I'll be able to answer more of your questions. Good. Now, the next question that we are going to encounter when it comes to algebra will be this one. Let's see, let's use black, let's blue. Let's try another color. Alright, the key with this one is that you'll see every time you put it in bracket, they will never miss it. So they say correct 2 decimal places. They are already telling you, don't go and try to factorize. There are no factors that you can find, but you can try. But to save time, this one needs us to go to your formula sheet and use our quadratic formula. But we need to make sure that x squared plus bx plus c is equals to 0. So you look at this one, we are trying to achieve this is equal to 0, where a is the coefficient of x squared, b is the coefficient of x, and c is just a constant. So you look at this one, you have a term that is on the right hand side. So we're going to transpose this term to the other side before we can start using the quadratic formula. So we're going to have 2x squared plus 5x minus 8 equals to 0. Let us move this to the other side, but because it was positive, it will now be a negative. Let's correct it. Let's correct that. So we're going to have 2x squared. This was positive, it will now be a negative 5x, and a minus 8 being equals to 0. And then we can see now that our a it is now 2. Our B is -5, and then our C will be a -8. But please also guard against the sides. Please, when you take the coefficient, please also take each side. So the sign here, because it's not written, is actually positive, and the constant is just -8. Be wary of those sides. So the quadratic formula, like we know it, will be x equals to -b plus minus b squared minus 4ac then over 2a. If you forget this formula, please go to your formula sheet and make sure you copy it as it is. It's sometimes we see learners writing the quadratic formula and doing this. Let me just show you in red so that you know that it's something dangerous to do. Learners will be saying x equals to -b plus minus then b squared minus 4ac over 2a. That's incorrect because everything must be inside the root. Yeah? And make sure that everything is under the division line. So if you are having a challenge with it, go straight to your formula sheet, copy it as it is, so they are able to avoid losing any unnecessary marks. So x will be equal to -b will be -5, because we said b was -5, and then plus minus the square root of our b squared will be -5 squared minus 4, and then our a will be 2, and then our c will be a -8. Everything over 2 multiplied by what is a is equal to 2. So you can press this in a calculator as it is. So let me see, if I press it on a calculator, we will have a minus -5, and then I'll start with the +1 and then the square root. Then I have 5 squared. Let me make sure I do the way I want you guys to do it. Open bracket -5, and then minus squared. Don't forget the square. I think you guys are a bit quicker than me. -4, and then a is 2, and then my c is -8. Close brackets, and then 2 times 2 should be 4, and then I press my answer. I get my answer. I think my answer will be almost something like that. I hope you're getting the same thing. And then when you press SD, it will give you 3,61. Remember, they said to 2 decimal places, eh? And then all, and then my x. When I press on a calculator, I'll press everything, but this time I'm going to use a minus, so I can just go back to my calculator. Quickly go to my calculator, let me check. And then this is a minus. Let's delete this. This is a subtraction sign. And then I simply get a -1, 1, because they said to 2 decimal places. You can also take a minute and verify. If there's any mistakes that we made, please do check them out. If you still need more clarity, please do let us know. Good. Let's move on. Remember, this is just to remind ourselves of what we're supposed to do in the 11, preparing for our next examination. Let's look at another example. This side, at least, we have the format is 5. We have a 0 on the right hand side. So our ax squared plus bx plus c is okay. So our a is 5, our b is 2, and our c is -6. So it means we go straight to substitute on our quadratic formula. So our x will be -b plus minus the square root of b squared minus 4ac, and everything over 2a. And then substitution will get you a mark. A correct substitution will get you a mark. X equals to -b. This negative has always been there. And then plus minus. And then b squared will just be 2 squared minus 4. What is a? Our a is actually 5. And then our c will be a -6. And everything divided by 2 multiplied by 5. And then you can press this in a calculator and get 2 values. Please to confirm those values. How much do we get? Let me quickly do mine. I'll have a -2, I'll have a plus, the square root, I'll have 4, and then plus 4 times 5 times 6. -2, and then plus the square root of 4, and then plus 4 times 5 times 6 plus bracket, then divide by 10. Yeah. I think we already found that. This will be 0.91 to 2 decimal places. And then if we want to look for the other one, minus, this will give me x equals to -1.31. So we have 2 problems. The first one is the basic factorization and solving for x, and the second one is the quadratic formula. So I'm not expecting anybody to be missing these problems. So it means the whole of question 1, we need to collect the whole of question 1, which will contribute almost 23 marks in your paper 1, 23 to 22 marks. So which will make a huge difference, because you need 45 marks at least to move to level 2. The hardest thing is to move to level 2, but once you get to level 2, every 5 marks will actually make sure that your level will change. So it's very important that we make sure that we collect the first question. Yeah? All right. If you have any more questions that we have, there's plenty of examples when it comes to such. So expose yourselves to such questions, and then you can do that by just going through previous papers and previous material to make sure that you are best when it comes to this. And then as we move, let's move into the next ones. And then here we come, the inequalities. I'm going to be a bit slow when it comes to these ones, because we tend to make a lot of mistakes, especially when we have found the critical values. I'm also going to explain a bit, also mentioning into functions, how we use functions to actually find those solutions. So because already we have done the topic functions in grade 11 and here in grade 12 we've revised in term 1 when we met. So I think it will make more sense. So let's look at the problem here. We always strive to get 0 on the right hand side, whether we have an inequality or an equal sign. It's called an inequality because it doesn't necessarily mean equals to 0. It's not necessarily equal. It's not necessarily an equal sign. So it's greater than or less than or greater than or equals to. So it's not necessarily an equal sign. Then we are saying this is an inequality. So with this one, we are going to transpose like we've always transposed. So we have 2x squared minus 2. I'm going to transpose this to the other side. It's going to be a negative 3x must be greater or equals to 0 because there's nothing left after transposing that. So for me to arrange it as a quadratic, I'm going to say 2x squared minus 3x minus 2 is greater or equals to 0. And then come the critical part. I'm going to factorize that. If we can factorize that, let's see, if we have this bracket, we'll say 2x, and then on the other side, we'll say x, and then we need to get a negative 3x, so I'm going to put a negative 2 this side, and I'm going to put a positive 1. Must be greater or equals to 0. So I'm going to start with what you're not supposed to do first, and then we go to what you are supposed to do. I'm going to erase it. You're not supposed to do this. When you get to this step, let me just put it. I don't know if you're going to see it. Let me just write it in blank. You can't do this now. 2x plus 1 must be greater than 0, or x minus 2 must be greater than 0. I don't want you to do that because we're dealing with the signs there, because it's greater than or equals to 0. So this will be a serious misconception. We cannot do this. We might be having one of the coincidences that this actually gives us the correct solution, but not always. And that's why I'm trying you guys to avoid doing this. So what we do is that we are going to treat this sign as an equal sign so that we can find the critical values. So you can say my critical values, then you can allow yourself to use that as an equal sign. So we can say 2x plus 1 not to do. And then in the same, in the same breath, let me erase it. And I hope that you're also erasing it from your brain, if that's how you are doing things. And then we have 2x plus 1, and then we have x minus 2. Remember, I wrote critical values, CV. It's not your character of time for finding a job. No, it's just to show that you are finding your critical value. So you can just use 0 for now to say, okay, I'm solving for my critical value. So 2x plus 1 equals to 0, or x minus 2 equals to 0. So x will give me negative 1 over 2. Transpose this to the other side and divide both sides by 2. And then or x will give me a positive 2. So I have my critical values. You're using this, you're equating this to 0 because you're trying to find the critical values. But the problem is this side. And then I'll come this side to solve my problem. I'm going to use a number now. And then this will be my x. So treat this in actual sense as an actual x-axis. And then remember 2x can just be y. So start with the smallest one of the critical values. You see that negative half is actually your smallest one. So you're going to put your smallest one, then come to your biggest one. This is actually 2. So remember this is a quadratic, so it's a parabolic graph. So I'm going to draw a parabola here with this as being the x-intercept. It's concave up, and you can see that a is greater than 0, so it's concave up. So if this is the x-axis, so it means anything above the x-axis will actually be positive in terms of y, will be positive. Anything below the x-axis will actually be negative. This is what our diagram is actually telling us, but we need to pick a solution. We cannot pick all the solutions. This is not a solution, it's a method of finding a solution. So our solution is we go back just when we were factorizing to say, we are saying we want to any values of x where 2x squared minus 3x minus 2 will be greater than 0 or equals to 0. Knowing very well that here they will be equals to 0, so it's included. Our solution must include negative half and 2. That's where our function is actually equals to 0. But greater than, when you see greater than, I want you to also get used to saying greater than or equals to anything greater than 0 is actually positive from any number line. If this is 0, anything greater than 0 will be this side, anything less than 0 will be this side. So greater than 0 simply means positive, less than 0 simply means negative. So it will be easier for you that every time you see something greater than 0, so that you don't confuse them, you actually remember it as something positive. Anything less than 0, you see them as negative. It will make your inequalities to actually be easy for you. And then let's take a look at the solution now. So we have 3 solutions. We see that we have positive ones are on the flanks, and then in the middle we have a negative one. So because we're looking for something positive, we're going to pick our solution this side and that side. So how we write them is also going to be very important. The solution for this part, we say x must be greater or equals to 2. It's included because we also want to include this 2, because we have seen in the critical values that for it to be equals to 0, the critical value must be equals to 2 or x must be equal to negative half. So we must include those critical values because it was included initially. Or your x must be less than negative half. Somebody can also say the same notation, because we are coming from this side. The solution will be coming from this side, because when we measure something, we measure from the left to the right. We can say where are we coming from? We are coming from negative infinity. We are coming from negative infinity. We are going to stop at negative 1 over 2. This is included because the negative half is also included. This bracket means that we are including it. The infinities cannot be included because you cannot include what you don't know. Yeah? And then x can also be an element from where? This will now start from 2 because we are measuring from left to right. It will be from 2 to actually positive infinity. Both will actually get the same mark. So finding your critical values will get you a mark. The 2 solutions will also get you a mark. So problems like this, I'm very, very, very sensitive with them, because we tend to rush them. Don't rush this one. Make sure that you are following. Like I'm saying, once you see anything greater than or equals to 0, you know that I'm talking about something that is positive. The problem could have been posed differently to say 2x squared minus 2 minus 3x, maybe it is greater than 0. Let me say it's greater than 0. then because this is not included, it means even our solutions will not be included. So I will have new solutions that look like this. X is less than -2, or x is greater than 2, because initially this was not included. So your solution will be included depending on how your inequalities was given at the beginning. I hope that makes sense to you. Good. So if you need to revisit, you can pause the video. You can also go back, and the link will be shared with you. Those that are currently live, if you still want to go there later on after the session, I'll be sharing the video link with the saved video link with everyone. Right. Now let's look at the other examples. I've placed 2 of them. That's what I'm saying. It's one of my favorite quadratics to do, because it has a lot of technicalities that you need to guard against. Let's look at this one. It's very easy to get lost with this one. So let me go and transpose it, because I said to you guys, you need to make sure you get the 0 on the right hand side. Right? So logically speaking, you will come and transpose. So I have a -7x squared. I'm transposing to the right hand side, and then this will change the sign, will be a 14x is less than 0. And I've placed this intentionally so that there's also, because this less than 0 is deals with the sign, whether it's positive or is actually negative. So this simply means negative. It simply means less than 0 is negative. But look at the value of a. The coefficient of x squared is actually negative. I like it to be positive to make my life very easy. So I'm going to multiply everything by a negative, or divide everybody by a negative, and I'm going to get a 7x squared minus 14x. But because this is a sign, the sign will also change. Whatever was negative will now become positive. So now instead of negative, now it will now become a positive. So it will change the direction. So this will be greater than 0. Because remember, an inequality is just telling us about the sign, whether it's negative or is positive. So now we are dealing with something, or we're looking for a solution that will be positive from our method. And then we can factorize. Make sure that you don't lose, because in the quadratic you must get 2 solutions. That the values are the same, but you must always have 2 solutions. So I always say try to factorize. Unlike transposing this to the other side and dividing by x, you're going to lose one of the solutions. So we're having a 7x squared. If you look at 7x squared, remember in grade 8, we're actually taking at the common factor. So we have a highest common factor of 7x. I'll be left with x, and then minus 2 must be greater than 0. And then we said we are going to utilize the critical values. Let's go and find the critical values. Our critical values will simply be equating this to 0, 7x being equal to 0, or x minus 2 being equal to 0. So my x will be 0, or my x will actually be 2. Let me just check if we still have a perfect view. I hope it's visible to everyone. Okay, and then let's go now to our solution. Remember, this is to help us with the critical values. So our solution will be here. The smallest one is 0 and the biggest one is 2. We're looking for something that is positive. The middle part will be negative. The reason why I like to multiply by a negative here is that I only have to deal with this type, a concave up graph. So this is negative and this will be positive every time. Because we can actually solve this without actually multiplying by a negative. But for now, because we're writing on Friday, you will have to master this one. So we're looking for something that is actually going back. We're looking for something that is actually solution that are actually going to give us our function to be positive. So we are getting a positive again this side. So our x will be greater than 2, or our x will be less than 0. Here we come this side. So somebody can also say x is an element of from negative infinity to 0. 0 is not included because this was not included to start with. X is an element of then from 2 to infinity. Yes, are not included because the initial inequality that is given to us was also not not included. Good. And then let's now try the last one. If you have any questions, please you can pose them. You can pose those questions, or you can send them on our WhatsApp group, and then I'll be able to elaborate more. And then we have x squared with this one. We have x squared on the right hand side. We're striving to get 0 on the other side. So is greater than, then we multiply, we have 3x, we're expanding this side, this multiplied by this, and this multiplied by this. Then we have 3 times 6, which will give us an 18. And then let's take everything to the other side. We transpose, we have x squared, we have minus 3x, we have minus 18, must be greater than 0. Here's our 0, we get excited. We have a 0 on the right hand side, so we get excited, so we can try to factorize this on the other side. We have an x, and then let's see if we use 6 times 3, and this will give us, because we're looking for a negative, so 6 and then plus 3 must be greater than 0. This was expanded so that we are able to see and deal with the signs. When you take it that size, sometimes let us make mistakes. Then we go to the CVs and we are saying x will be equals to 6 or x equals to negative 3. This is what is happening when you go to the CV. We are equating, we are not saying it's equals to 0, we are just equating to 0 to get the critical values. So your x will actually be 6, x plus 3 be equals to 0, so x equals to negative 3. Even if this is not shown, and you write that the critical values is x equals to 6 or x equals to negative 3, and then we can make use of the number line, which makes it much easier for us. So we have a negative 3, which is the smallest one, and the biggest one, which is and this will be a negative, this will be a positive on the other side. And then we are picking our solution, and unfortunately this is also a positive one, so our x will be greater than 6 or our x will be less than negative 3. So I'm just going to make things interesting for this one because I want us to actually be exposed to one problem that actually is negative so that we see how we pick the middle solution. Yeah? So let me save this and then we'll do our own. We just change the sign. We change the sign. Let's discuss this one. Let's say the problem was saying we had x squared less than 3x plus 6. So we're going to have x squared, same method, 3x plus 18. Then transpose everything to the other side. So we're going to have x squared minus 3x minus 18 is less than 0. And then we have seen the critical values was x equals to negative 6, x plus 3. Is less than 0. So let me just do it quick on the other side. My CV, like we got them as x equals to 6 or x equals to a negative 3. So our number line will be this way. We draw it this side. Forget about this. So our CV, x equals to 6, x equals to negative 3, so it's going to be negative 3, it's going to be 6. Let me just do my function this side. This will be negative, this will be a positive. And then I want to pick the middle one because they're saying it must be less than. Remember, less than is negative. So the negative solution is this side. How do we write this one? We write it as negative 3 less than x and 6. Or somebody can say x is an element of not including them from negative 3 to 6, not included. So those are our two possible notation on how we represent the middle part. So if that was included this side, this will just be included, and the bracket this side will just be squared. Yeah, so go through different problems and see if you are able to do them by yourself. And if you still can't, before you go to sleep tonight, you must make sure that you are able to do so. If not, please do contact me with immediate effect. Yeah? All right. All right, we have another inequality. There's plenty of examples. This one will actually have one that actually is negative, but let's see how far it goes. If we arrange this, this will be let's move that inside. If we arrange this, so this will be a negative 2x squared plus 4x is less than 0. And then, like I said, I don't like to work with an a that is actually negative. The same applies to people who are negative. Ne? I also don't like to work with people who are negative. The same applies to maths. Ne? So I'm going to change these negative people to become positive, ne? By motivating them. So I'm going to motivate them with somebody who is negative 2. So I'm going to multiply by a negative number here. So it's going to be 2x squared minus 4x. Then this will change because I'm multiplying by a negative value. So this will change the direction. And then we can solve now by taking out the highest common factor, which will be 2x, and then x minus 2 is greater than 0. Then I'll find my critical values. 2x, x minus 2 equals to 0. So x equals to 0 or x equals to a positive 2. So build my x-axis with my x being equals to 0 and then my other x being equals to 2. You always start with the lowest one, then go to the biggest one. This is actually a number line. It's an x-axis. It says anything below the x-axis will be negative, anything above will be positive. So this will be negative, this will be positive. I think we've done plenty of this. By now you should actually know how to write the solution. So x must be greater than 2 or x must be less than 0. This becomes our two solutions. All right. We'll move on to your next question. Let me just also give you a bit of time just to take a breather a bit. If maybe you want to go and stretch your legs, yeah, you can move 5 steps and come back. Because we have a train to catch there, and our train is leaving on Friday. Alright, let's move on. If you still need more, go back. And then let's go to SAS. The SAS that we're taught in grade 11. There's a very interesting thing about SAS, because you need to isolate the SAS. One thing that you need to make sure is to isolate the SAS. And how do you know something is a SAS? You see it with a square root. Every time you see a square root, then you know you are having a SAS. Yeah? So once you see you want this to be by itself. Remember, we always want to have 0 on the right hand side. But when it comes to the SAS, we need to make sure that the SAS is by itself. It doesn't matter what is on the right hand side. So things are changing now. We're going to transpose this. We want to remove this because we want to leave the square root on the left hand side. So this will just be a square root of x plus 6 must be equals to, because this has moved to the other side, it will be 4 plus x, which is the same as x plus 4. Let's rewrite so we can be able to see it properly. We have x plus 6 being equals to x plus 4. You cannot take this 6 and now transpose it to the other side because it's under the square root. Also be careful of that. And then we're going to square both sides because we are getting rid of the square root. Squaring both sides, we'll remove the square root on the right and the left hand side, x plus 6. And then this side we'll have x squared plus 8x plus 16. Remember what I said last time? I said if you have a square and you want to expand this very quickly, you square the first term, which will give us x squared. Then you take x, you multiply it by 4 together with this sign, it will give you 4x, and then multiply by this 2. X multiplied by 4 multiplied by this 2 will give me an 8x, and you take this 4 and you also square it, and then it will give you 16. The quicker way of expanding, but if you still want to open the bracket because you have more time and you know you can catch up, we've multiplied this by that, it gave us x squared, we multiplied this by that, it gave us 4x, we multiplied this by this, it gave us 4x, we multiplied this by this, it gave us 18, and eventually it gave us this solution. And then as we move on in our problem, you can say you're transposing everything to the other side so that you don't deal with the x squared, which is negative. So you will say 0 on this side, and transposing this to the other side, transposing that to the other side. We're going to have x squared plus 8x minus x, which was coming from the side, and then plus 16, and then minus 6. So it means we have x squared, which is equal to 0, plus 7x, and then plus 10. And then we have to factorize that. 0 is equal to x squared plus 7x plus 10 is the same as us saying, if I was to write this, I don't know if you will be able to see that. Let me just erase this part, so we can utilize most of the board. Move this to the other side. And then we continue. So we'll have x squared plus 7x plus 10 being equals to 0. And then this we can factorize to say this is the same as x plus 2 and then x plus 5 equals to 0. So our x will be equals to negative 2, or our x will be equals to a negative 5. If you cannot factorize, go straight, you still have the quadratic formula. You can use the quadratic formula as soon as you get here, because you have ax squared plus bx plus c being equals to 0. You have that 0, you have that c, you have that b, and then you have that a. So you can use the quadratic formula if maybe you cannot get the factors as soon as you would like to. So you have x equals to negative 2 and x equals to negative 5. It doesn't end there with such, because sometimes one of the answers is not a solution. So you need to go and substitute and check. So you need to check them. You can check that on a scribbler or on a piece of paper. It's up to you. You just have to come back and show us that which one is a solution and which one is not a solution. So let's take x equals to negative 2. If we put x equals to negative 2, let's say for example, we have a negative 2, and then we have a plus 6, and then we say minus, this was negative 2, and see if it's going to give us 4. So negative 2 plus 6 will just literally give you 4. So we'll have 4. Negative times negative will be positive, will be plus 2, which is not equals to 4. So it means this is not a solution. You come back and cancel it. You can test, let's test 5. Oh, but we have plus x, eh? So I wrote it wrong. Plus 2 plus negative 2 plus negative 2. So it was minus 2. So this would give me 6. So either way, this was actually 2. So either way, it's not giving us the solution that we actually want. Let's see with 5. Let's see with 5. If we check 5, we have the square root of negative 5 plus 6 equals to or minus, but it's 5. Yeah, no, it's okay. It's okay. The first problem is okay because the plus came this side, so I looked at it twice. So it's 5. Yeah, do you see what I mean? I looked at this, and then my eyes moved here. So the square root of negative 5 plus 6, and then let's say minus negative 5 must give me 4. So this will give me 1. So I have the square root of 1, then plus 5 must give me 4. So this will be 1 plus 5, which will give me 4. So this is also not a solution. So both of them are not giving us a solution. So we can go back and recheck where we went wrong and see if there's any mistake that we actually made during our calculation. Let's move it from this side. We have square root of x, then we move the x to the other side. It was positive, so we get s squared plus 8x plus 16. And then we move this to the other side, minus, it gave us 7, it gave us a 10, so everything was fine this side. We have x squared plus 7x, then the factors are okay, x equals to negative 2, x equals to negative 5. We checked negative 2, we said if we put negative 2, that side is going to give us a 4. The square root of 4 is 2. And then minus 2 is actually equals to 4. So this one is actually the one which is a solution, the x equals to 2. Let me sort that one out quickly. The first check. Right. With the first check, I had a square root of negative 2 and then plus 6 and then minus negative 2 must be equals to 4. This thing is going to give us 4. Then this was 4, so the square root of 4 and then plus 2. So this is 2 plus 2, which is equals to 4. So this is 5. Let me just fix this quickly. I knew that something is not right here. So my x equals to negative 2 it is a solution. This is the one that is not a solution. Yeah? Thank you. Let's fix that. Good. That's why I love this certain inequalities. Yeah? You know where something is not right. Let's move in to see if we can try another problem. We move straight to the K method, and then let's take a look at what we have here. Okay. So it means that with the SATs, you need to go and do more problems when it comes to your SATs. But if you still have problems that you want us to do together, you can actually send them through, and we can actually do them together. This one looks like a SAT. I've selected this one on purpose because it looks like a SAT. We can solve it as a SAT, but it will take us longer. So, but because you see a repetition of the same thing, like if you look at this, you have a square root, and it's very daunting to be working with square roots every time. You try to remove the square root every time. So if you have more than one square root in an equation, don't use the SATs and isolating it. It's just going to take you longer. Not like it's impossible to solve, but it will take you longer. So what I will do, I'll make to say, okay, let me just, because I see this as a repetition of the same thing. What can I say? Let K be equal to that I see that is actually appearing twice. Equals to the square root of 2x plus 5. I'm trying to improve this handwriting. And then wherever I see square root of 2x plus 5, I'll put k. So I'm going to have k minus 3 over k equals to a negative 2. And then I don't want this k to be a denominator, so I'm going to multiply everybody by 2 by k. I'm going to multiply by k, multiply by k, multiply everybody by k. So I will now have k squared The k will be gone because that's what I was trying to achieve, minus 3, and then negative 2k. Then transpose this to the other side, I will have a k squared, a positive 2k, and then a minus 3 being equals to 0. And then we can solve this, we can factorize this easily, and then it will be k minus 3, the positive 3, and the k minus 1 being equals to 0. So my k value equals to 3, negative 3, or my k value equals to a positive 1. Remember, we're not solving for k if k is a variable that we brought in ourselves. So we need to solve for x. So I know sometimes people will try to factorize this and they will use the quadratic formula and say x equals to negative b plus minus the square root of b squared minus 4ac over 2a. You cannot use the variable x because now you are solving for k this side. So please use k. Use it as k. Yeah. Then you can solve for k because you are going to say a repetition of the wrong thing. We are going to say x equals, and when you come back to the truth, it will just be confusing. So if we are using the quadratic formula to factorize, please look at the variables, check the variable we are trying to and then use them. Let's go back to our problem, and then we're going to say when k equals to negative 3, so it means we have a square root of, remember we said k is equal to the square root of 2x plus 5, so we have 2x plus 5 being equals to negative 3. We're going to square both sides, we square both sides, almost like now it's a side now. Then we have 2x plus 5 being equals to 9. Transpose this to the other side, we have 2x. If you put it this side, it's going to be a minus, so it's going to be 9 minus 5, which will be 4. So our x will simply be 2. And then when k equals to 1, remember we have square root of 2x plus 5 being equals to 1, we square both sides, 2x plus 5 being equals to 1, squaring both sides, and then we have 2x, take it to the other side, being equals to a negative 4. So our x will simply be a negative 2. So we have two values of x, like we said, these are quadratic. So you normally get two solutions. Actually, you always get two solutions. Sometimes it's appear at as one. It's just that they have two equal roots. So it looks like it's just one, but it's just two roots that are equal to each other. Yeah, I hope it makes sense. We'll then jump into another one. If you still need to make sense of this, I'm going to take a 5 minutes break. So we'll be back again at It's now almost 20 past 1. So we'll come back at 25 past 1. But I'll leave this here. Or in the meantime, look at the problems that I have for you. While I go and take a break, just a quick break. Alright. Can't indulge in this in the meantime while I take a break. So they can also shade with other letters who are writing in the problems as well. So they can shade it. Alright, back. Let's take a look at this such problems. When you look at a glance, they look like your simple exponential, taking out a common factor, dividing by that common factor on both sides. But in actual sense, these are the same problems that we had on the other side, where we had to bring in another variable. So you can be any variable that you want. So if I look at this 4x and I see a 2x again, and if I take a 16 to the other side, it's not going to help me anyway because I still have a 2x. So what I would do is to always, when we're dealing with exponents, use the prime numbers. So this is the same as 2 to the power of 2. Come on. So this will be 2. We'll use blue now. 2 to the power of 2. This is for the 4. We had that x already. And then minus 16 is equal to 6 multiplied by 2 to the power of x. Writing this into its prime factors will not help us for now. So we have 2 to the power of 2x minus x equals to 6 multiplied by 2 to the power of x. And then we're going to can I use k again? Yeah, let me just use k being equals to 2 to the power of x. And then this one will simply be k squared minus 16 equals to 6 multiplied by k, because this I said must be equal to k. And then we can simply see that the problem now becomes easy, because now I have a k squared minus a 6k minus a 16 being equals to 0. We can use the quadratic formula this side. We can factorize. Let's try to factorize. We have k. We have k being equal to 0. Factors of 16 is 6 times 3. And then my k is equal to 6. Or my k is equal to -3. So we do the same thing. When k is equal to 6, it means 2 to the power of x must be equal to 6. And then we come this side, it means 2 to the power of x must be equal to -3. I need to also verify something. It's 4x, 16, 6 times 2. This is 16, we are fine. That side we have 6 times 3. It's negative. Oh, yeah. We have a different one that side. Yeah? So we have 9 times 3, 16. The factors of 16, let's just correct that. Let us correct this, because this is going to give us a -3. Right? Let's fix this quickly. And then we get the factors of -6. So we can get -6. So what are the factors of 16? Let's verify the factors of 16. We have 16 being equals to 8 times 2. So we have k, and then because we're looking for a -1, -8, and then k plus 2 must be equals to 0. Please also check the mistake that I made. You can also easily make that mistake. Please fix that, because we're looking for -6, not 3. So our k is equals to 8, or our k is equals to a negative 2. So when k is equals to 8, you'll have 2 to the power of x being equals to 8. And then this side will have 2 to the power of x being equals to negative 2. Thank you. Alright. And then for this one, there was no solution this side because we can see that this one is a positive exponent. A positive exponent will never give us a negative value. From exponents, we have now exponential format. It means we're going to have a graph of this kind. It will never come to a negative side. Right? So it will always be an increasing graph. So there's no solution for it. And then this one, we can just raise it to the power of 3, 2 to the power of 3, and then therefore our x will be equals to 3. I hope we're okay. Please guard against those factors mistakes. Especially if I'm doing it in a rush, eh? Alright. Okay. So I'm going to end this material. So we can be able to solve this one on the right. Alright, the one on the right. Let me just use the whole space. The one on the right also looks very simple, very straightforward, but it's not. It's 4 to the power of x minus 2 to the power of x equals to 2. So what we have here is, if we can try to say, okay, let's try to take out a common factor, we still have to have the power of 2x. So we'll do the same thing to say, let this be 2 to the power of 2x minus 2 to the power of x equals to 2. And then we're going to let k be equals to 2 to the power of x. And then we're going to have k squared minus 2k equals to 2. And then we continue to simplify. This will come on the other side, 2k, this will be a positive, a minus, changing the sign, coming this side, the negative 2, equals to 0. Therefore, let's move into this space. We'll have k, open bracket, and then we're going to have a minus 2k. So let's see if we're going to get the same solution this side. So our k will simply be a negative 2. Can we factorize this? Which is a negative 2 multiplied by a negative 1, and we are not going to be able to factorize that. Do we have factors of that? We don't have the factors of that. It's negative 2. Factors of negative 2 will be negative 2 and negative 1. These are the only factors that we have. It's negative 2 and 1. So we cannot be able to factorize this. And then somebody can also say we will have a negative square root of 2. And then no, we cannot be able to factorize this. K plus square root of 2. Let's check again and verify and see if we didn't do any mistakes on any of the sides. We have 4 to the power of x, which is 2x minus 2x equals to 2. And then if we let this, we end up with that. Then we have a negative 2, then we have this. Am I erasing it? So we have k squared minus 2k and then minus 2 equals to 0. And then I think we're going to get a decimal on this side, because if we use the quadratic formula, we'll have k equals to negative b plus minus b squared minus 4ac. See if we have a solution this side. Okay? Good. Let's see if we have a solution, or we can use any other method to see if it's going to work for us. So our k will simply be negative b minus negative b, and our b will actually be negative 2, and then b squared, negative 2 again, squared minus 4. What is a? A is actually 1, and then c would actually be negative 2 over 2 times a, and then my a is just 1, so my k will simply be a positive 2, and then plus, minus, let me just check if we can do it by here, which is 4, and then plus 8, which is 12, and then over 2, so my k value will simply be 2, and then plus 12, then divide by 2, so my k will just, this will just be 2 divided by 2, which will be 1, plus 1 over the square root of 12 over 2. So this will be our 2k values, and the other one will be k equals to negative 1 minus square root of 12, and then over 2. So this can be equated to 2 to the power of x. Let's see if we are able to do it. We can put this in a calculator and see how much it gives us. Right? It was just one of those problems. Right? We'll end up looking for alternative methods. And then, yeah. You can press this in a calculator and see how much it gives us. And then we have other methods of doing it. I was not expecting you to give us that. So this will be 1 minus the square root of 12 and divide by 2. I'm getting a decimal on the side, which is 0.732. And then k this side will be plus. Two comma 73. So with my knowledge for now, I'm going to have 2 to the power of x being equals to 2.73, and then I will say my x will be and then my x value almost 1.5. And then let's see this one. And then my x value negative 0.732, which is impossible. So this one is not a solution. The only solution that we have is this one. So we have that problem. I will also come back to this problem and see. Can also verify if maybe the question was also written correctly. But if the problem was correctly written, then we're gonna have to come up with other ways to solve it, which means that we're going to be introducing our log. So we have 4 to the power of x, which is the same as 2 to the power of 2x minus 2x equals to 2. Then we let k equals to 2 to the power of x, then we have k squared on this side, and then minus 2k, which is equals to 2. Then we transpose this side. We've realized we cannot factorize this. We use the quadratic formula to do it, and it gave us 2 decimal 2,73. Then we use the logs, and we found that approximately our answer is 1,45. And then we now move into our next to do, which is that I hope that is clear. We have 2 to the power of 3x plus 1 plus 2 to the power of 3x. This one is different from the other ones, because when you look at the loss of exponents, we said we can reverse this, the product of 2 exponents. So this will be the same as 2 to the power of 3x multiplied by 2 to the power of 1. This comes from when you say a to the power of n multiplied by a to the power of m. Because they have the same base, you keep the base and you add the exponents. So we're actually going backwards. And then plus 2 to the power of 3x, because I can see a 3x this side and 3x this side. I will try to take out a common factor. So my common factor, you see that 2 to the power of 3x, which is appearing on both before the plus sign and after the plus sign. So I'll take out 2 to the power of 3x. It will give me 2 to the power of 1, which is left that side. This side, if I hide it, I'm left with nothing, it's just 1 is equals to 12. And then if you see that if you can say let k equals to 2 to the power of 3x, you see this will just be k. It will also be easy for you to recognize. But this one is not challenging. So you have 2 to the power of 3x, and then inside the bracket is 2 to the power of 1 plus 1. So this will be 3 equals to 12. And we divide both sides by 3 because we're trying to find the value of x. So we try to isolate everything that has x. So 3 will divide 3, and I'll be left with 4. So for the sake of space, I have 2 to the power of 3x equals to 4. 2 to the power of 3x, this as a sub, as the factor of its prime numbers will just 2 to the power of 2. But because now they have the same base, it means the exponents are also equal. So therefore 3x must be equal to 2. This is equivalent to this because this is equal to this. Let's do it in different time. Because this is the same as this. That's why this is equal to that. Because this is equal sign. And then I want to solve for x, so my x will simply be 2 over 3. That will be our solution for 1.1.4. Go also take a look at such problems in your grade 7 material. I'm also going to send some material so that you can revise with. All right, let's move on. Practice, 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 practice. Let's see what we have. Yeah, and then we are going to be dealing with 2 parts. So the first part that I wanted you guys to know, we are done with it. Let me just go back and recapture what we we were discussing. Yeah, we had 4 of them. We have the simple finding the factors and solving for x. We had also quadratic formulas. Using the quadratic formula, you will say by definition, you will see it will be written in brackets to 2 decimal places. And then we have inequalities that we also need, find a way of solving them, practice more of these questions. And then we have the one that we have to use the K method to actually solve it. And then now we're going to move to the second part, which is what we normally enjoy doing, simultaneous equations. Good thing about the grade 12s and the grade 11s is that you only are given 2 variables to solve. So we have x and y. It can be x and z, it can be z, but you will only have 2 variables to solve. So in any mathematical problems, if you have to solve 1 variable, you need 1 equation. If you have to solve 2 variables, you need 2 equations. If you have to solve 3 variables, you will need 3 equations, so on and so forth. So the number of variables that you need to solve is dependent on the number of equations that you need to actually solve them. So yeah, this one only need 2 variables, so that means you're going to use 2 equations. If you don't see the equation, you must find it is hidden somewhere. And then we'll talk about a bit of nature of roots. This is what we did in grade 11 in depth. So once you start hearing when the roots are real or when the roots are rational, we'll also be using the discriminants to be able to find our solution, which is coming from our quadratic formula. All right, let's jump straight into it. How to solve for x and y simultaneously. For this one, you are given 2 equations. You must always start with the one that is easier to simplify, making sure that you make x the subject of the formula or y the subject of the formula, whichever is easier for you to make the subject of the formula. So between the 2 equations, I'm going to pick this one because I can see that I can make y the subject of the formula. The good thing that's this side, y is the subject of the formula. So what we can do, let's say this. Let me just say 3x minus y plus 2 equals to 0 is equation number 1. And then my y is equals to negative x squared plus 2x plus 8 plus 8, let me switch that, plus 8. I hope you can see this. On the other side, this will be equation number 2. Right, I'm gonna jump right into the middle. Right, I can decide to say, because already I have y as the subject of the formula, I'm going to say substitute equation 2 into 1. And then wherever I see y, I put x squared plus 2x plus 8. So I have 3x. This is my 3x. Negative y. Remember my y is just negative x squared plus 2x plus 8. And then this is the 2. And then plus 2 equals to 0. And then I simplify. Say 3x. This will be a positive x squared, a negative 2x, a negative 8 plus 2 will be equals to 0. And then we are simplifying and collecting the like terms. I have an x squared, which is the one with the highest power. And then I have a negative 2x and a positive 3x. This will give me a positive x. I have a negative 8 plus 6, which will be a negative 6, being equals to 0. and then I need to simplify this by factorizing it. I'm going to have x and then minus 3, let's say plus 3, we can get positive 1, and then x minus 2 must be equal to 0. So my x is negative 3, or my x equals to a positive 2. And then the problem doesn't end there, because I also need to solve for the value of y. So I'll take the y first. When x equals to negative 3, my y will simply be a negative 3 squared plus 2 times negative 3, and then plus 8, and then my y will be, and pressing the calculator as it is, we have a negative, close brackets, negative 3 squared, and plus 2, open bracket, negative 3, and then plus 8. You see, I'm just pasting it as I see it, and press equals to sign, that my y equals to negative 7. And then the second one, I'm using this because y is going to be the subject of the formula, but you can use any of the equations. When x is equal to 2, so my y will simply be a negative, and then I have a 2 squared plus 2 multiplied by 2, and then plus 8. So my answer this time, you can put this in the calculator, this will be 4, negative 4 plus 4, so my answer will just be 8. Let us verify. So our answer will just be 8. So we have two x values. As soon as they say solve for y and x simultaneously, in most, not or in almost all of them, because this one we call the quadratics, you find two values of x and you also find two values of y. Good. Any questions, please post them on the comments or on the group. Alright, let's move into the other two problems. I think the other one is solve for x and y. We are given two equations still, and then we have to solve both of them simultaneously at the same time. So let's start with looking for the equation which is easier for us to make one. We get the two. You see that we have y squared plus x squared plus 10x plus 5. This is too much work for us to make one of them subject of the formula. We come this side, we have x already, we have 2y. So what we do, we'll pick this one and say let's simplify this one. Making x a subject of the formula is easier. So I'm going to have x equals to, take the 5 to the other side, take the x also to the other side. So I'm going to have a negative 5. I'm also going to have a negative y on the left hand, on the right hand side. And I'm going to call this equation number 1. I just transpose them to the right hand side. I haven't done anything to them yet. No need to remove the negative yet. It's okay. Take it as it is. And then this will just be called equation number 2 as is. This has been simplified, but it's still the same equation. If this was equation number 1, this will still be equation number 1. It's just the simplification version of it. Simplified version of it. Sorry. So I'm going to substitute equation 1 into equation 2. So I'm going to have y squared. This is the y squared I'm talking about. And then plus x squared This is the x that I'm talking about, but I'm going to substitute a negative 5 minus 2y. Remember this one squared, and then plus 10, negative 5 minus 2y plus 5 equals to 0. And then let us now simplify. I would like to put this as a bigger bracket so that I can be careful of the size. Like we said last time, you can square this, the negative 5 by itself, it will give you a 25. And then you multiply this 2, a negative multiplied by a negative will give you a positive. A 5 multiplied by 2 will give you a 10. And then we have a y, so it's going to be a 10y multiplied by 2. This will give us a 20y. And then we have a negative 2. This will give us positive 4y squared. And then those with trust issues, as always, let's do it here. Negative 5 minus 2y. Negative 5 minus 2y. This multiplied by this will give us a 25. This multiplied by this will give us negative times negative will give us a positive 10y. This multiplied by this will give us another positive 10y. And this multiplied by this will give us a positive 4y squared. So this two added together, they are giving us a positive 20y. That is in the middle. So this is the quicker way of doing it. So every time when I have anything that is squared, if I have a plus b and it is squared, I know that my answer will be I square the first term, take the first two, multiply them together, and they'll give me ab, and the 2 that is outside as a power, I just multiply by it, and then the last one, I just also raise to the power of 2. So if you have any problem, you can quickly get this, as long as the bracket is actually being squared. Right, and then we move into the side. Undo. Let's take red. This will be multiplying that. This will give us a negative 50. Let me just go back to erase this. This multiplied by that will give me a negative 50. This multiplied by that will give me a negative 20y. And then plus a 5 that is isolated on the other side. I can remove the bracket safely now. Y squared, I have 25. I have a 20y. I have a 4y squared. And then I have a negative 50. And I have a negative 20y. And then plus 5 equals to 0. I'm doing this because sometimes you find that there's a negative. You have to, when you remove this bracket, you need to multiply every term by that negative. So get used to when you're removing the bracket, you're going to have to do a lot of things in one line. So now let us collect the line terms. I have a 25 and I have a 50 and I have the 4y squared. I have the y squared. Let me just use blue. I have the y squared moving with the 4y squared, and then yellow, I'll just highlight the y's. Yeah, the y's, I'll just take it also with the sign. And the constants, don't forget, also have a 5. So we're going to add the y squared, will give us a 5y squared. We've dealt with those ones. Just come with the y, we have 20y minus 20y, so they are gone. Don't have the y's anymore. And then 25 minus negative 50 will be a negative 25, and then it will be a negative 20. Equals to 0. Then let's move move this a bit, see if we can squeeze it in here. Then we can solve for y. So our y will simply be, we can divide both sides by 5. So we have, if we divide by 5, it will be y squared minus 4 equals to 0. If we divide everybody by 5, we divide by 5, we divide by 5, we divide by 5, it will lead us to y squared minus 4 equals to 0. I'm doing this on purpose because let's come this side, let's pay attention to this side. Let me just use a different character so to show you what is very tempting. This is very tempting for you to say. You can say 5y squared minus 20 equals to 0, and say 5y squared, transpose this to the other side, and it actually gives you 20, and you divide both sides by 5, divide both sides by 5, then you have 5y squared, then you equal to 4, and then you square root both sides, and you say y is equal to 2. If you do this, please don't forget, when you put a square root, you must always say y is equal to plus minus 2. So your solution here is y is equal to plus minus 2, but you don't forget it. So when you have it this side, you can simply say y minus 2y plus 2 equals to 0, because there's a difference of 2 squares. So we have y being equals to 2, or y being equals to negative 2. Also, don't forget to find the value of x for both of them. So for this one, when y is equals to 2, your x will simply be negative 5 minus 2 times 2, and then my y will simply be a negative 4, so this will just be a negative 9. And then this side we have x negative 5 minus 2 times negative 2. This will be a positive, so we have positive 4, so my x will simply be a negative 1. Please also check that. Check this problem out. The straightforward simultaneous equation problem. They need you guys to practice them. And the more you do them, the better you will become in solving them. And yeah. Let me just create a bit, okay? I didn't say that. All the slides will also be taken from the drive and be sent to your individual self, except that one because I didn't say it. Yeah? This one. So you can try it again. You know the values. And yeah, the nature of roots. But before we solve this problem, I want us to discuss something very quickly. Just a summary and remind ourselves what we know. Let me start first by saying we remember this. I think we just used it just now when we say x equals to negative b plus minus the square root of b squared minus 4ac all over 2a. And then from this, I'm going to focus here. This part. Take out this part and call whatever is inside that part, put it with a triangle, right? So the type of solution we're going to get will be determined by whatever is inside the triangle, because we know that in mathematics we don't want anything that is negative inside the square root, because the whole thing will not, as far as mathematics is concerned, will not be real, it will be imaginary. But we'll do that when you get to your first year of university. But for now, for you guys, we said they are not real, they are non-real. Né? Not like they're impossible, they are non-real. And then in mathematics, it means something else. Né? They exist, they are just not, they are what we call the imaginary number, but we'll learn about them as we move forward. So we have real and rational roots and so forth, but I want us to focus in what we can easily make sense of. So when the discriminant, which is b squared minus 4ac, is greater than 0, it means we know that even if it's equal to 0, our roots will be real. We'll have real roots, and then if our discriminant is less than 0, we'll have them as non-real. And then let's say specifically when this actually equals to 0. So it means that the whole thing will be 0 this side. So we're going to have this as a solution. Negative b over 2, because the whole thing will be 0. So it means that we'll only have, we'll see this as giving us one root, but it's not actually one root, it's just two equal roots. So they are actually going to be equal. So it means that if it's just this alone, there will be a real, and then there will be non-equal. Because it's greater than 0. So here they are just real, they can be equal, and they can also be non-equal. But if it's less than 0, we know it's, they are non-real. And then if they're equal to 0, they are real. It's just that they are equal. And if it's greater than 0, they are real and equal. This can be written as a fraction because most of them will be, just when they are real, most of them will be rational. And then you will see that if it's actually a perfect square. If this is a perfect square, it means that this will be a whole number to the side, and this will be a b will always be a whole number for us, divided by another whole number. So this will make the roots to actually be rational because they can be written as a fraction. But I want us just to focus on this part for now, just to remind ourselves to say if it's greater or equal to 0, we know they are real. If it's less than 0, it means they are non-real. If it's equal to 0, it means the roots are equal. If the discriminant is what we call this, triangle, it represents this. So it's the discriminant. It will tell us the type of roots we are going to find. Hence we call this the nature of roots. What type of roots do we have? So once you start hearing questions like, for values of k, find the roots are real and rational for all values of k, you need to know that. You need to know what's happening with the discriminant. I hope that makes sense. Where are you? Let's save this. Alright. And And then let's come to such problems. Now we have show that the roots of 3x squared plus k plus 2 plus x and then 1 minus x squared. So the are real and rational for all values of k. So it means what we want the discriminant for them to be real. No, good. We want them to be real, so we don't want them to be less than 0. They can be equals to 0, they are still real. They can be greater than 0, they are still real and rational. So let's focus on this is A. Coefficient of x, it will be b, and even if we transpose this to the other side, it will become c. So let's transpose it. We have 3x squared plus k plus 2 x. Then we transpose that to the other side, is going to be a minus 1 and then a positive k being equals to 0. So this will be a constant by itself. So we want the discriminant to be greater or equals to 0. It must be real and it must also be rational. So what we're going to do is that we have a equals to b, so we're going to say b squared minus 4ac must be greater or equals to 0. So what is b? My b is actually k plus 2 squared minus 4. What is my a? My a is 3, and then my c is negative 1 plus k, which must be greater or equals to 0. We're going to simplify this on the left hand side. So this side, the big bracket will give me k squared plus 4k and then plus 4, and then this will be a negative 12 multiplied by a negative will be a positive 12, a negative 4, it will be a negative 12 multiplied by a positive k will be a negative 12k. Must be greater than 0, and then we are going to solve for k. So we're going to simplify it with the bracket. So I'm going to have a k squared plus a 4k plus a 4 plus a 12 minus a 12k must be greater than 0. Our further simplification, let me just draw a line on the side. We have a k squared, and then we have 4k minus 12k will be a negative 8k, and then we have a 4 plus 12 will give us a 16, and then must be greater than or equals to 0. And then we have to go and find the factors of 16. That's when we multiply them together. Let's check if everything is fine. We have 4k negative, which is 16 negative 8k. Good. No, we are fine. Now, what are the factors of 16 that we know? We have 1 times 16. Not close. We have 3. And then we have 3. Not 3. We have 6 times 3. Will give us 12. Give us 18. No. And then we have 9 times 2. We have 9 times 2. Can we add 9 times 2 to give us 16? What other factors do we have for 16? So we also have 4 times 3. Yeah? 4 times 4 not 4 times 3, 4 times 4, 4 times 3 is 12. So we also have 4 times 4. So we have k. I can see 4 plus 4 is actually 8. I'll pick those ones, easier. I have 4. And then it means my k, because there's an inequality. So my critical value is k equals to 4. So it means that if we look at the critical value here, it was the same one. When I have something of this kind, just so that we can understand from the one that we did last time, because I'm having the same value repeating itself twice, so it means that the turning point is also the x-intercept. So we say, what are the values of k? So xk, for k to actually be positive, an element of all integers. This is a critical value of 4. So we want it to be positive. So this graph will never be negative. So k is an element of all integers. I hope it makes sense. So from negative infinity to positive infinity, the value of k will give us the roots that are real and rational for all the values of k. Good. And then we'll take another, it's now almost 20 past, we'll take another, I'll take another 5 minutes break. And then in the meantime, I will also leave a problem on the board for those who are online. No.
Tutoring. By tutoring. YouTube channel. What's your handle or situation? As a living solution. Due to operate. 10 to 12. Okay. I trim. With my games bag, my ideas. Yes, I would actually go home and have it. I am home. So, yes, that's such a next year. In effect. Mr. Ndo. ndiyatsho ngoba ndizembethuswa ngumzali. There's something I wasn't sure about. Like other language, other Nguni languages probably also have. Oh, makes sense. Profoundly. Yeah, I found you have already subscribed.
Thank you. All right. Let's move on. We have, I hope you can see that. This one we have f at x equals to 5x squared plus 6x minus 7. And because we come from, our last topic was calculus, I think you'll be excited to see f at x. F at x is just y, like we said. And they say solve for x if f at x equals to 0 to correct the two decimal places. Here it comes again. So what is it telling you? It's simply telling you go and use the quadratic formula. Stop stressing yourself. Go and try the factors. Let us go and use the quadratic equation. So let's see. So we have f5x squared plus 6x minus 7 being equals to 0. And then we say our x will be negative b plus minus b squared minus 4ac, everything over 2a. And then we can just simply substitute negative b. B was 6. And then b squared was 6 squared minus 4, my a is 5, and then my c is negative 7, and 2 multiplied by 5. So you get two values there. Pressing on the calculator, you get two values. Done this a couple of times. To the next question. All right. This next question says, hence or otherwise calculate the value of d for which f at x plus 6x minus d equals to 0 has equal roots. Remember what I said about the discriminant. You need to know when you see equal roots, what is required from you. And then from what we have discussed when we were just recapturing, we said if we say something has equal roots, it means that we are saying the discriminant is equal to 0. So all of that is going to be left is going to be negative b over 2a. So it's the same as the turning point of the parabola. That is that point. Equal roots. So 5x squared plus 6x minus d. So it means that b squared minus 4ac must be equals to 0. Let me just move this. Equals 0. Not 0. That's 0. Okay? So what is my b squared? My b squared is still 6. So I have 6 squared minus 4. And then my a will simply be 5. And then my c will simply be negative d, which is equal to 0. And then we can simplify that. This is going to be 36. And then this is going to be 20. And it's going to be opposite 20 because there's d. Negative multiplied by negative will be positive. 4 times 5 is equal to 20d equals to 0. and we can simply solve this to say, all right, now I have 20d being equal to a negative 36. We divide both sides by 20, and then my answer will be negative 36 over 20. When you press this in a calculator, see if you can simplify that. It will simply give us 9 over 5. So, but if we leave it as negative 36 over 20, you still get those full marks. So please check out these programs. Most of them you will find them in grade 11 question papers. It's very rare to find them in grade 12 question papers, but the examiner can ask you anything, because now, remember, this is not taught in grade 12, so there's no specific types of problem that we ask in grade 12. We ask all of them from what you've learned from grade 1 until to grade 11. So most of the nature of rules, they are asked nicely in grade 11. They are not there in grade 10. So you can find them in some of the grade 12 past question papers, but just go and practice a few of them so that you can just have a feel of those. So that's the end of algebra for today. So we are going to leave this live session and we're going to enter into another one for financial mathematics, specifically for grade 11. So it is now almost 2:30. So exactly at 3:15. We'll be starting with finance. It will also take 2 hours. Good. Yes.
The hardest working man in the AC.
Huh?
The hardest working man in the AC.